A car's transmission is working against itself every single day. Every gear shift wastes energy, creates noise, and adds hundreds of pounds of dead weight. But what if next-generation cars won't need traditional multi-speed gearboxes at all? This isn't some distant fantasy, it's happening right now. Companies like Lamborghini are already building supercars using revolutionary axial flux motors, specifically YASA, or yokeless and segmented armature, designs that drastically reduce reliance on complex gear systems and deliver instant power the moment the pedal is pressed. The technology that makes this possible will change everything you think you know about how cars work. But first, it's important to understand the problem these motors are designed to solve. Every time a car speeds up, it's fighting a 150-year-old problem. Its transmission wastes 15% of engine power before it even reaches the wheels. These traditional systems suffer from three core issues: wasted energy from friction, significant extra weight, and mechanical complexity. These aren't just minor flaws, they limit a car's potential daily. During a gear change, drivers rarely notice a brief dead zone where no power reaches the wheels. The engine runs, fuel burns, but for those critical milliseconds, energy vanishes. Race car drivers know this as the torque gap, the enemy of smooth acceleration. Inside, hundreds of metal gear teeth constantly grind under pressure, generating heat and stealing power. Modern transmissions with over 300 moving parts inherently lose power this way. A typical automatic transmission alone can lose about 15% of engine power just moving its own components. The transmission's weight further compounds problems. An 8-speed automatic weighs 180 to 220 pounds, like carrying 2 extra passengers. This dead weight sits low, raising the car's balance point and forcing more energy use for every acceleration or turn. High-performance transmissions can exceed 250 pounds. This mechanical complexity leads to constant inefficiencies. Gear wind signals imperfect meshing, and shift clunks and jolts through the car. This same complexity makes transmissions one of the most expensive repairs. Hundreds of rubbing parts wear out, clutches degrade, valves clog, gears loosen, and torque converters fail. Each part is a potential breakdown point. Oddly, even modern electric vehicles often use traditional transmissions. Electric motors provide instant power without gears, and yet manufacturers still add these heavy, complex, and inefficient systems. It's like using a typewriter to send an email. It misses the point of simple, direct power. Solving this century-old problem requires completely rethinking how engines and motors deliver power. How axial flux motors work. The solution to old power problems comes from a radical idea. What if magnets spun sideways instead of in circles? This isn't a small engineering change. It's a complete rethink of how electric motors make power, fundamentally changing how vehicles operate. Traditional electric motors use what engineers call radial flux design. Imagine the magnetic force pushing outward from the center, like spokes on a bicycle wheel. Magnets surround a cylinder, creating a spinning force. This works, but it's not the most efficient. Axial flux motors flip this idea. Instead of magnets around a cylinder, they face each other across the flat disc. The magnetic force flows sideways along the rotor's center, like two spinning plates with an invisible pool between them. Here's the interesting part. Radial flux motors are everywhere, while axial flux motors have largely remained rare due to manufacturing hurdles. The powerful magnetic forces trying to pull these facing discs together required heavy iron frames to stop the motor from tearing itself apart. The YASA breakthrough changes everything. YASA stands for yokeless and segmented armature. This design eliminates the heavy iron frame found in traditional motors. Instead, YASA uses custom bindings and advanced materials for a much lighter structure. The segmented armature divides the copper wires into individual pieces, allowing coolant to flow directly through them for better cooling. Think of it this way. Radial motors are like pushing a merry-go-round from the outside, fighting against its resistance. Axial motors push from above and below at the same time, creating a more direct and powerful push. The magnetic force hits the copper wires head-on, not at an angle, maximizing efficiency and minimizing wasted energy. This pancake-shaped design directly transfers power without needing gears to multiply the force. While radial motors often rely on complex gear systems, axial flux motors create massive power directly. This means instant power the moment electricity flows through the motor. No gears means no power interruptions, no delays, and no energy loss from metal parts rubbing together. The power-to-rate ratio truly shows the advantage. Each YASA motor, like those in the Lamborghini Ruvelto, weighs just 17.3 kilograms, or about 38 pounds, but produces 110 kilowatts, or roughly 148 horsepower. It's barely thicker than a large pizza box at just 70 millimeters thick. The segmented design offers another key benefit: cooling. Gaps between the copper wires allow coolant to flow right through the motor's core, enabling high power output for longer without overheating. Traditional motors struggle with heat buildup in their dense copper windings, which limits performance during extended use. Axial flux motors deliver instant, smooth power by removing the complex mechanical parts that traditional systems require. They create a direct path from electrical energy to wheel movement. No gears, no delays, no power interruptions, just pure electrical force converted directly into motion. This technology isn't just theoretical, it's already powering some of the world's most advanced vehicles, fundamentally challenging everything known about car engineering. The Lamborghini Ruvelto hypercar uses 3 separate motors to control each wheel with incredible precision, moving beyond traditional gears entirely. This fundamentally shifts automotive engineering, utilizing 3 YASA axial flux motors to challenge how we've always thought about power delivery. It's not just about making cars faster, it's about creating vehicles that react like living organisms.